So today we are going to discuss chapter 4 exercise 4.5. Chapter 4 on determinants, exercise 4.5. In the last class we already learned what is meant by minor and cofactor, okay, of a determinant. We have already studied that, so I'm not going to explain that. Let's try to understand what is meant by adjoint of a matrix. Adjoint of a matrix. So let's try to understand the term, okay? Adjoint of a matrix. Very simple. Just consider that last class also I highlighted on how to find the adjoint, okay? Just a rough representation. We'll be using that method, but you need to learn how to define it, okay? So suppose A is any matrix. Let's say that A is a square matrix of order n. Then if A is a matrix, then the A should be represented by Aij, square matrix of order n. So it has n rows and n columns. This is how we represent a matrix, right? No? Just so A is any matrix. So this is how we represent a matrix, square matrix of order n. Now, adjoint of this matrix A is the transpose of the matrix Aij. Now, adjoint of this matrix is the transpose of this matrix capital Aij of order n, same order. Is it okay? Where this Aij is the cofactor of this small aij. Where this aij is the cofactor of the elements of this matrix, small aij. Are you following that? No? Yes. So that is known as the adjoint of your matrix, and the adjoint of a matrix is given by adjoint of A. Okay? Now, any matrix A into times the adjoint of A is always equal to adjoint of A into your matrix A. So this adjoint of A and your matrix A satisfies commutative property of multiplication. Are you getting me? Actually, in general, matrices, they do not satisfy multiplicative property or commutative property of multiplication. They do not. Some they do, but in general they do not. But in this case, okay, the commutative property of multiplication is true for any square matrix A. Okay, and this product is equal to the determinant of your matrix A times your identity matrix of order same to that of your matrix A. Here A is a matrix of order n, so here I should be the identity matrix of order n. If A is a matrix of order n, then adjoint of A will also be a matrix of order n. Then the identity matrix that you use should be of the same order n. Is that clear? No? With a matrix. So that is how we define the adjoint of a matrix. Now, there are some things that you need to know. Singular, singular matrix. A matrix is said to be a singular matrix if the determinant of A is equal to 0. I think that's correct. If the determinant of A, so as matrix is said to be a singular matrix. Matrix means we're talking about square matrix here, okay? So a matrix, a square matrix is said to be a singular matrix if its determinant A is equal to 0. In such a case, for those matrices, they are not invertible. Means their inverse does not exist. Okay? But a matrix is said to be non-singular. A matrix is said to be non-singular if its determinant is not equal to 0. Determinant 0 no hilihi non-singular. If the determinant of your matrix is 0, then that matrix is said to be a singular matrix. And if the determinant of your matrix is not 0, then the matrix is non-singular. And if the matrix is non-singular, then inverse of that matrix exists, and we can find it. Is it all right now? Yes. So that's all. Is it okay? That's the concept that we wanted for this exercise 4.5. Okay. Yeah. Let me repeat about this adjoint. It can be a bit confusing for you. That's what I feel. What you do is you just consider a square matrix. Let A be a square matrix. Then matrix is represented by Aij. I'm considering A is a square matrix of order n and cosine. Okay, so this is your matrix A. Then adjoint of this matrix, okay, adjoint of this matrix is the transpose of the matrix, capital Aij of the same order, okay, where Aij, this Aij is the cofactor, of the elements of this matrix. It is Aij. Is it okay? Now, we just say that is known as the adjoint of a matrix. I can show you some example. I will show you the example of a 2 cross 2 matrix first. Suppose, okay, before that, and there's other definitions also. Singular matrix, a square matrix is said to be singular if its determinant is equal to 0. And the square matrix is said to be non-singular if its determinant is not 0. And for a singular matrix, its inverse always exists. Is it okay? Yes. Now, let's consider an example that A is a square matrix of order 2. 1, 2, 3, 4. Let me find out the cofactor of the elements of this matrix. Cofactor of this element. This element belongs to first row and first column, right? Now, cofactor of this element shall be represented by A11. Okay? A11. So it will be given by what? Minus 1 to the power 1 plus 1, and then you are finding the cofactor of this element. So in that case, you need to neglect this element belongs to the first row and first column. So neglecting the first row and first column, we have 4. So times 4. So that is minus 1 to the power 2 is positive, plus 1. So 1 times 4 is 4, right? Cofactor of this element is in first row and second column. So cofactor of this element will be given by, okay, actually how you have to write is cofactor of this element is A11. This is an element belonging to the first row and first column, so A11. Okay, so and the cofactor is represented by capital A. 1, 1, right? So minus 1 to the power 1 plus 1, okay, times minor of this element, right? Minor of this element means, okay, yeah, you neglect this element belongs to first row and first column, you neglect first row and first column, we have 4. Okay. Now cofactor of this element. Now this element too, it belongs to first row and second column, and the cofactor of this element will be denoted by A12. Now this element belongs to first row and second column, so you neglect first row and second column, then we have 3. So the formula is minus 1 to the power 1 plus 2 into 3, right? So that is equal to how much? Minus 3. This will be equal to 4. This is equal to minus 3. Cofactor of this element. Cofactor of this element belongs to second row and first column. So capital A21 is equal to minus 1 to the power 2 plus 1. Cofactor of this element means this element belongs to this row, second row and first column. You neglect second row and first column, what do we have? 2. So times 2. Minus 1 to the power 3 is minus and 2, right? And then the cofactor of your remaining element, this element 4, it belongs to second row, second column. So the cofactor of this element will be represented by capital A22. So minus 1 to the power 2 plus 2 times. This element belongs to second row, second column. So you neglect this row and this column. So we have 1. Minus 1 to the power 4 is plus 1. So 1 into 1. Is it okay? So adjoint of your matrix A will be given by the transpose, transpose of the cofactor of the elements of this matrix. So kinakalaki A11, A12, right? No? Adjoint of A means transpose of what? Yeah, transpose of the cofactor of the elements of this matrix. Cofactor of A11 is capital A11. Cofactor of this element A12 will be capital A12. Cofactor of this element, this element is A21 will be capital A21. Cofactor of this element will be capital A22, right? So adjoint of A is given by the transpose of the cofactor of the elements of the given matrix. So in that case, your A11 is 4, capital A12 is minus 3, capital A21 is minus 2, capital A22 is 1. Transpose, right? No? So the transpose of this matrix, transpose means the first row will become the first column, 4 minus 3, right? And the second row will become the second column, minus 2. Is it okay? Yes. So this is the definition. According to the definition, adjoint of a given matrix is defined as the transpose of the cofactor of the elements of the given matrix. Alright? Yes. But whenever you come across a 2 cross 2 matrix, okay, instead of applying this definition, what we can simply do is, suppose A is your matrix 1, 2, 3, 4. I want to find out the adjoint of your matrix A. Now, instead of finding its cofactor and instead of transposing it, what you can do is, for a 2 cross 2 matrix, what you can do is, you just exchange the diagonal elements, and to the anti-diagonal elements, we write its additive inverse. Are you getting me? Now, to the diagonal, we exchange the diagonal elements, And to the anti-diagonal elements, we write its additive inverse. We don't exchange the anti-diagonal elements. We write that on the anti-diagonal elements, we write its additive inverse, and then we exchange the diagonal elements. That's how we find out the adjoint of a 2 cross 2 matrix. But for a matrix of order greater than 2, like 3 of a matrix of order 3, matrix of order 4, definition is required. Is it okay? Yes. So using these definitions and some of these some of these terms, we will try to solve the first exercise. The first question of this exercise, not the first exercise. So exercise 4.1, question number 1, what do we have? Find the adjoint of each of the following matrix. Okay, 1, 2, 3, 4. Okay, let's see like this. Let's do it this way. Let A be your matrix. What is that? 1, 2, 1, 2, 3, 4. This is what I have done just now in the example, so I don't want to repeat. Okay, so question number 2. Question number 2, we have a matrix A is equal to 1 minus 1, 2, 1 minus 1, 2, 2, 3, 5, 2, 3, 5, minus 2, 0, 1. No? Okay. So we need to find out the adjoint of this matrix. Now we know that adjoint of a matrix, okay, adjoint of a matrix, this is a 3 cross 3 matrix, right? This is a matrix of order 3. So adjoint of a given matrix is the transpose of the cofactor of the elements of this matrix, right? Now, no. You find out the cofactor of all these elements of this matrix A, and then you transpose it. That gives you the adjoint of the matrix. Na? Ito matrix A de kiman elements ase sob laga cofactor pisariwo aro transpose koridibo. To adjoint of A by jabo. So we need to find out the cofactor of all these elements of your matrix A, okay? Yes. So, cofactor of this element. Cofactor of this element. This element belongs to first row and first column, right? So, A11, no? Cofactor of this element will be denoted by A11. It is given by minus 1 to the power 1 plus 1 times the minor of this matrix. What is the times the minor of this element? What is the minor of this element? Minor of this element is the determinant obtained by neglecting the row and column to which your element belongs, right? Yeah? Ito element laga minor pisari bole nimite tai kundu row ase kundu column ti ase ito neglect koribo aro remaining laga determinant lo. Ngano to kiman obe. So this element belongs to first row and first column. So neglecting, we take the determinant of the elements neglecting this row and this column. Okay, no? So determinant of 3, 5, 0, 1. Okay, so that's equal to here minus 1 to the power 1 plus 1. Minus 1 to the power 2 is positive 1. So 3, 1 times is 3 minus 0, that is equal to 3. So we have obtained the cofactor of this element. Now, the same way we have to obtain the cofactor of all these elements. Okay, this is going to take a very long time. So cofactor of this element, this element minus 1 belongs to first row and second column. Okay, so definition says minus 1 to the power 1 plus 2 times the minor of this element. Minor of this element means the determinant obtained by neglecting the row and column in which this element lies, right? So this element belongs to first row and second column. So neglecting first row and second column, we take the determinant of the remaining. 2, 5, minus 2, 1. Minus 1 to the power 3 is negative. 2, 1 times is 2. Minus 2 times 5 is minus 10. So I write plus 10. So that is minus 12. Alright. Cofactor of this element 2. Yeah, this element belongs to first row, third column. So A13 definition says minus 1 to the power 1 plus 3. And then we take the determinant, neglecting the elements or neglecting the row and column in which this element lies, right? 2, 3, 2, 0. 2, 3, yes, minus 2, 0. Minus 1 to the power 4 is positive. So 2 times 0 is 0 minus 2 times 0 is 0 minus 2 times 3 is minus 6, so plus 6. So 6, right? Now we find out the cofactor of the elements of R2. This element 2 belongs to second row and first column, right? So that's minus 1 to the power 2 plus 1, and we take the minor of this element. Minor of this element means the determinant neglecting the row and column to which this element belongs. So we neglect this row, second row and first column. So we take the determinant of minus 1, 2, 0, 1, right? So minus 1 to the power 3 minus. Is it correct?
Minus 1 to minus 2. 2, 1.
No. Minus 1 to 0, 1, right? So this is equal to minus 1 times is 1, or minus 1. Minus 1 times, this is minus, and then minus 1 times 1 is minus 1. Minus 0 times 2 is 0. So this is equal to plus 1. Now we take the cofactor of this element. This element belongs to, this element 3 belongs to second row, second column, right? So definition says minus 1 to the power 2 plus 2. And we take the minor of this element. Minor of this element means determinant of 1, 2, minus 2, 1, right? 1, 2, minus 2, 1. Is it correct? So that is minus 1 to the power 4 is 1. 1 times 1 is 1 minus 2 into 2 is minus 4, so plus 4. So we have 5. Now we go for A23. Okay, A23 means minus 1 to the power 2 plus 3, and the minor of this element. Minor of this element means 1 minus 1, 2 minus 2, 0. 1 minus 1 minus 2, 0. I hope it's correct. No? So minus 1 to the power 2 plus 3, minus 1 to the power 5 is negative, and then 1 times 0 is 0, minus 2 times minus 1 is 2. So that is 2, right? Now we go for the third row. Let's find out the cofactor of the elements of the third row. This element belongs to third row and first column. So definition says minus 1 to the power 3 plus 1, and we take the minor of this element. Minor of this element means minus 1, 2, 3, 5. Minus 1, 2, 3, 5. Okay? So minus 1 to the power 4 is positive. Minus 1 times 5 is minus 5. Minus 3 times 2 is 6. That is minus 11. Now we take the cofactor of this element, 0. Definition says minus 1 to the power 3 plus 2 times the minor of this element. Minor of this element, you neglect this row, this column, then 1, 2, 2, 5, right? 1, 2, 2, 5. Minus 1 to the power 5 is negative. 1 times 5 is 5 minus 4. That's minus 1. And then your A33. Your A33 will be minus 1 to the power 3 plus 3, and the minor of this element, that is 1 minus 1, 2, 3. 1 minus 1, 2, 3. So that's minus 1 to the power 6 is negative. 1 3 times is 3 minus, correct? 2 times minus 1 is minus 2, so this becomes plus 2. Huh? Minus 1 to the power 6 is positive, okay. 1 3 times is 3 minus, and then 2 times minus 1 is minus 2, so minus minus plus, that is how much now? 5. So your adjoint of A, is given by what? Transpose of the cofactor of the elements of this matrix, right? Cofactor of this element will be capital A11. Cofactor of this element will be capital A12. Cofactor of this element capital A13. Cofactor of this element capital 21, capital 22, capital 23, capital A31, capital A32, capital A33. Now we fill up capital A11. 3 minus 12, 6, right? 1, 5, 2. 1, 5, 2. And then we have minus 11, minus 1, and 5. So the transpose of this matrix, alright? Transpose means the first row becomes the first column. 3 minus 12, 6. Second row becomes the second column, 1, 5, 2. Third row becomes the third column. So that's the adjoint of your matrix. Can you check the answer? We cannot afford to make any mistakes, okay? Otherwise we need to change the, we need to check on the entire things that we have worked out. Okay. Then let me try another one. For the beginners, this question, solving this kind of question can take hours. Okay, but once if you are used to it, then it may take maybe 10 minutes. Okay, maybe 10 minutes to find out the adjoint. If you practice harder, then you take lesser time. So it depends on individual. Okay. So let me. Okay, in number 3 and 4, in question number 3 and 4, we need to verify the matrix A times adjoint of A is equal to the adjoint of A times your matrix A, and is also equal to the determinant of A times your identity matrix. So I'm going to do number 4. 1 minus 1, 2. 3, 0, minus 2, 1, 0, 3. So this is your given matrix, and we have to verify this condition. So let's see how we do this. So solution, let A be your matrix. 1, minus 1, 2, 3, 0, minus 2, 1, 0. So in order to find out the adjoint of this matrix, let us find out the cofactor of all the elements of this matrix. This time we'll do directly, okay? Directly means we can just find out the cofactor. Cofactor of this element will be what? Yeah. Cofactor of this element will be minus 1 to the power 1 plus 1. Is it okay? And then the minor of this element. Minor of this element means determinant, okay, of the elements obtained by neglecting, determinant obtained by neglecting, yeah, the row and column that this element belongs, right? Okay. Now see, A11 formula will be minus 1 to the power 1 plus 1, which is positive, right? See, 1 plus 1 is 2. So minus 1 to the power 2 will be positive. And the minor of this element, 0 into 3, 0, minus 0 into minus 2, 0. So 0. Okay, I'm not going to write all these minor things now. Now, cofactor of this element here, cofactor of this element, A12, will be, here 1 plus 2 is 3, minus 1 to the power 3 is negative, right? And then the minor of this element will be, this element belongs to first row, second column. Huh? So you neglect first row and second column and find the determinant of the remaining elements. 3 times is 9. Minus 1 into minus 2, minus 2. So plus 2. So that's minus 11. Okay. Then A13, cofactor of this element. 1 plus 3, 4. 4 is positive. Minus 1 to the power 4 is positive. So I'm not going to write any sign here. Yeah. So you write the minor of this element. Minor of this element will be determinant of 3, 0, 1, 0. Right? Determinant of 3, 0, 1, 0, right? So 3 times 0 is 0, minus 1 times 0 is 0. So that's 0. Getting more zeros so easy for us, okay? Now A21, 2 plus 1, 3, minus 1 to the power 3 is negative, and we write the minor of this element. Minor of this element will be minus 1, 2, 0, 3. Minus 1, 2, 0, 3, right? So minus 1 into 3, minus 3. Minus 0 into 2, 0. So that is plus 3. A22, 2 plus 2, 4, minus 1 to the power 4 is positive. And the minor of this element will be 1, 2, 1, 3. So 1, 3 times is 3, minus 1, 2 times is 2. So that is 1, right? And A3 or A23, minor of this, cofactor of this element. 2 plus 3, 5, minus 1 to the power 5 is negative, and then minor of this element will be 1 minus 1, 1, 0. Determinant of 1 minus 1, 1, 0, right? 1 into 0, 0, minus 1 into minus 1, minus 1. So plus 1 now. So minus plus, minus 1. Now A31, cofactor of this element, minus 1 to the power 3 plus 1. So minus 1 to the power 4 positive. And the minor of this element will be determinant of minus 1, 2, 0, minus 2. Minus 1 times minus 2 plus 2. Minus 0 into 2, 0. So that's 2. Similarly, A32 will be 3 plus 2, 5, minus 1 to the power 5 is negative. Minor of this element will be 1, 2, 3, minus 2. 1 into minus 2, minus 2, minus 3 times 2 is 6. Minus 2 minus 6 minus 8, minus 8 times minus is plus 8. And then A33 will be positive of 1 times 0 is 0 plus 3, that is 3. Okay? So your adjoint of A will be the transpose of the cofactor of the elements of this matrix. So this is 0, minus 11, 0, 3, 1, minus 1, 2, 8, 3, right? Yes. Okay. Alright. So the transpose of this matrix will be, first row will become the first column, second row will become the second column, third row will become the third column. Now we need to verify this one. Let's take the left hand side. What is your left hand side? Your left hand side is A into adjoint of A. Your A is 3 cross 3 matrix. 1 minus 1 2, 3 0 minus 2, 1 0 3. And adjoint of A 0 3 2 minus 11 1 8 0 minus 1 3. So let's multiply these two. Let's multiply these two. If you remember how to multiply, first row will multiply first column. That will be your first element. Is it okay? Yeah. Both of the matrices are of order 3 cross 3. So the resultant matrix should also be 3 cross 3. Their product. No? First row or first column can multiply with 1 0 0. Minus 1 into minus 11 is 11. Minus 2 into 0 is 0. Now first row will multiply second column. 2 into 1 into 3 is 3. Minus 1 into 1 is minus 1. 2 into minus 1 is minus 2. First row will multiply third column. 1 2 are 2, minus 8 plus 6. No? Second row will multiply second column. 3 times 0 is 0. 0 times minus 11 is 0. Plus minus 2 times 0 is 0. Second row, second column. 3 times 3 is 9. Plus 0 times 1 is 0. And plus minus 2 times minus 1 is plus 2. Huh? Second row will multiply third column. 3 2 times is 6. Plus 0 times 8 is 0. Plus minus 2 times 3 is minus 6. Third row will multiply. Now third row will multiply first column. 1 into 0 0. Correct? 0 into minus 11 0. 3 into 0 0. Third row with second column. 1 into 3 3. Plus 0 into 1 0. Plus 3 into minus 1. Minus 3. Third row with third column. 1 into 2 2. Plus 0 into 8 8. Plus 3 into 3 9. 0 into 8 is 0. So this is 11 0 0. Right? 0 11 0 0 0. Oh, this is a diagonal matrix. Huh? Diagonal matrix. Also, all the diagonal elements are 0, rest implicit 0. Now let's go for the right hand side. Right hand side means adjoint of A times A now. So adjoint of A times A. Adjoint of A is 0 0 3 2 0 3 2 minus 11 1 8 0 minus 1 3. And your matrix A 1 minus 1 2 3 0 minus 2 1 0 3 2 multiply koribido. First row with first column. First row with first column. 0 into 1 0 plus 3 into 3 9 plus 2 into 1 2. Second row with second column. 0 into first row with second column. Yes, thank you. 0 into minus 1 0 plus 3 into 0 0 plus 2 into 0 0. We have to make sure that only the diagonal elements will be 11. Rest everything is 0, okay? 0 into 2 is 0. Plus 3 into minus 2 is minus 6.
Plus 6. Still plus 6. 2 into 3. The next one minus.
Yeah, next one will be plus 6. Okay, I thought this is plus. Now second row with first column. Minus 11 into 1 minus 11 plus 1 3 times is 3 plus 8 1 times is 8. Minus 11 into minus 1 11 plus 1 into 0 0 plus 8 into 0 0. Second row with third column. Minus 11 into 2 minus 22. Oh my God. Plus 1 into minus 2 minus 2 plus 8 3 times is 24. Okay. Third row with first column. 0 into 1, 0, minus 1 into 3, 3, plus 3 into 1, 3. Third row with second column, 0 into minus 1, 0, plus minus 1 into 0, 0, plus 3 into 0, 0, and this is third row with third column, 0, 2, 0, 0, plus minus 1 into minus 2, plus 2, plus 3, 3, 0, 9. So 11, 0, 0, 0, 11, 0, 0, 0, 11. So they are equal, but we need to go for the third one. Determinant of A times psi, we need to show that is equal. So determinant of A, okay, left hand side, right hand side, what do we call this? Other side. Okay, we need to show that all the three quantities are equal, right? Three quantities are equal. So let us see how far it is equal. Okay, we need to find determinant of A. So determinant of A will be determinant of 1, minus 1, 2, 3, 0, minus 2, 1, 0, 3. I'm going to expand this determinant on the row or column having maximum 0, C2.
We can use question number 4, 3 and 4 shortcut. No, not in 3 cross 3. Only
2 cross 2.
Oh.
2 cross 2, we can find adjoint only. Okay, not other things. Only the adjoint.
Sum of elements.
Oh, what you're saying is you want to use that property here.
Oh, yes.
Okay, it's alright. So let me expand it along C2. Okay? Expanding along C2. I have wrapped all the cofactors now, so I can use that. So expanding along C2 then, minus 1, we take this minus 1, then minus 1 belongs to this row, right? First row and first column, and you cross multiply the remaining elements. 3 3s are 9, 3 3s are 9, right?
Yes.
Minus, and then 1 into minus 2, so plus 2. After that, the next element is 0, next element is also 0, so everything will be 0. So in that case, this is minus 11.
Oh, minus 1. Minus 11.
This is minus 1, no? So I'm getting minus 11. Then I should get plus 11, no? A. What is the problem here? I think this is no problem. Do the correlation now. 1, minus 1, 2, 3. Expanding along C2 seems to be correct. Okay. Okay. Let me do this straight away. Determinant of A is 1, minus 1, 2, 3, 0, minus 2, 1, 0, 3, no? It will determine. Let me expand along R1. Expand along R1. Okay? So, if we consider this element, then you neglect this row, first column, you cross multiply the remaining. 0 into 3, 0, right? Minus of 0 into minus 2, 0 again. Minus this element. This element is minus 1, right? And then we cross. Now, this element belongs to first row and second column. So we neglect this row and this column. We cross multiply the remaining elements. 3 into 3, 9. Minus 1 into minus 2, so plus 2. It's correct. Plus this 2 times, into 2 assists, so 2. Now this element belongs to the first row, third column, so neglecting that, we cross multiply the remaining elements. 3 into 0, 0 minus 1 into 0, 0. So 0 minus minus plus 1 into 11 plus 0. So that's 11. Right? Therefore, determinant of A times I. Determinant of A times I. Determinant of A is 11 times your identity matrix of order 3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. So you multiply by 11, 11, 0, 0, 0, 11, 0, 0, 0. Is it alright? So all the three quantities are equal. Therefore, A times adjoint of A is equal to adjoint of A times A is equal to determinant of A times your identity matrix. Okay? And that should be enough for me to explain now. So similarly, you work out with all the questions. Okay? Oh, find the inverse if it exists given in 5 to 11. No? Okay, I'm going to show you that. I'm going to show you that. So the next type of question will be finding the inverse of the given matrix. Finding the adjoint of the given matrix. See, you need to know that a matrix, a square matrix is invertible. Let me say this. A matrix of order n, of order n, in square matrix, is invertible if the matrix is non-singular. Only if your matrix of order n is non-singular, only in that case it is invertible. Okay, so a matrix of order n is invertible if it is non-singular. Alright, non-singular means determinant of A should not be equal to 0. Alright, and in that case it is invertible. And the inverse of any matrix A, inverse of any matrix A is given by the formula adjoint of A divided by determinant of A. Adjoint of A divided by the determinant of A gives you the inverse of the matrix A. Alright? Yes. So let us try one. Find the inverse of each of the matrices if it exists. Means you need to check whether it exists or not. Inverse exists or not. In 5 to 11. Let me do one for 2 cross of order 2 and let me do one for order 3, okay? And the rest will be yours. Let A be your matrix. 2 minus 2, 4, 3. 2 minus 2, 4, 3. And then let me do number 7. Number 7 is 1, 2, 3, 0, 2, 4, 0, 0, 5. Let's see how far we can get to it. So this is your matrix. We want to find its inverse if it exists. Let's check if it exists, okay? A is your matrix, so determinant of A will be determinant of 2 minus 2, 4, 3. So finding the determinant is very simple. Just cross multiply. 2 3 times is 6 minus 4 times minus 2 is minus 8. So 6 plus 8 is equal to 14, which is not equal to 0. Therefore, A inverse exists. Okay. Therefore, A inverse can be obtained by adjoint of A divided by the determinant of A. So let me simply find out the adjoint of A. Finding adjoint of a matrix of order 2 is very simple. Just exchange the diagonal elements now and write the additive inverse of anti-diagonal elements. Is it correct? Therefore, A inverse will be adjoint of A divided by determinant of A. Adjoint of A divided by determinant of A. Can I write like this? No? Adjoint of A divided by determinant of A. 1 upon determinant of A to kya ase 14 aro adjoint of A to 3 to minus 4 so we multiply each of these elements by this 1 by 14, right? Now 3 upon 14 1 upon 7 minus 2 upon 7 1 upon 7. Can you check? Correct, no? Okay, it's all right. So let me go for number 7, 3 cross 3. Adjoint of A. Number 7, let A be your matrix 1, 2, 3, 0, 2, 4, 0, 0, 5. Shall we check whether A inverse exists? Determinant of A will be determinant of 1, 2, 3, 0, 2, 4, 0, 0, 5. Let me expand it along R1. 1. Arrow ito. You neglect this row, this column, cross multiply the remaining things. 2, 5 times is 10. Minus 0, 4s are 0. Right? Yeah. Ito minus and this element 2. Ito element loide. First row, second column jabo. First row, second column jabo to cross multiply the remaining things. 0 into 5, 0. Minus 0 into 4, 0, right? Ito element plus ko ito lo 3. Ito element loide first row, third column chai jabo. So 0 into 0, 0 minus 0 into 2, 0, right? So 10 minus 0 plus 0. So 10, which is not equal to 0. Therefore, A inverse exists and we shall find it. We shall find it. So let me find out the adjoint of this A. In order to find the adjoint of this matrix, we need to find out the cofactor of all its elements, no? A11 will be minus 1 to the power 1 plus 1, so positive. And then we write the minor of this element. Ito element la minor, no? Determinant obtained by neglecting the row and column that this element belongs, right? So ito la determinant of ni, na? Ito la determinant of kyo. 2, 5 times is 10. Minus 0, 4 times is 10. A1, 2 do. Oh, 1 plus 2, 3 minus 1 to the power 3 is minus. Ito la ka do? Ito la ka minor do? 0, 5 times is 0, minus 0, 4 times is 0. So 0 minus 0, 0, right? A1, 3 do positive ho.
Next one also 0.
Yeah, ito element la ka minor do. 0 times 0 is 0, minus 0, 2 times is 0. So 0, no? 0 minus 0. A21. A21. I'm writing all these zeros extra only for the viewers. Otherwise, we could have done that without writing all this now. A21. Ito element la ka minor, no? Oh, A21, 2 plus 1, 3. So negative, no? Positive, negative, positive, negative, yeah. Ito la minor, no? Zuk, zuk. 2 5s are 10. Minus 0, right? 10 minus 0, that will be 10. Minus 10. A22. A22. Ito lakay. 1 5 times is 5 minus 0 3 times is 0. 5 minus 0 5. A23. A23. Okay, ito lakay. Ito laka minor do. Oh, A23 2 plus 3 5 minus 1 to the power 5 minus. Ito lang minor do. 1 0 0 0 minus 0 2 0 0. 0 0 minus 0, 0. Right? A31, what about A31? Minor. Ito lang ang minor. A31, 3 plus 1, 4. Yeah, minus 1 to the power 4 positive, so ito lang minor. 2 4s are 8 minus 6, right? 8 minus 6, 2, right? What about A32? Huh? What about minor of this element? 1 4 times is 4 minus 0 3 times is 0. 4 minus 0. 4 minus 0. That's minus 4, right? No? What about this one? Minor of this element? 1 2 times is 2 minus 0. 1 2 times is 2 minus 0. 0 2 times is 0. So that is 2. Therefore, adjoint of A. Adjoint of A means transpose of the cofactor of the elements of this matrix. So 10 0 0, 10 0 0, minus 10 5 0, minus 10 5 0, 2 minus 4 2, 2 minus 4 2. So ito lang transpose to. First row will become the first column, second row the second column, third row the third column. Therefore, A inverse is equal to determinant of adjoint of A divided by the determinant of A. So 1 upon determinant of A is 10, and the adjoint of A is 10 minus 10, 2, 0, 5 minus 4, 0, 0, 2. So you multiply all the elements of this matrix by 1 upon 10. So that will be 1 minus 1, 1 by 5, 0, 1 by 2, minus 2 by 5, 0, 0, 1 by 5. Is it correct? Well, that's it. Okay. So I think you should be able to do up to number 11. Okay, you try up to number 11.
In the answer though, they just did it unmultiplied.